So we're going to look at the negatives on the inside and outside of functions, and we're going to relate those to vertical and horizontal flips. So just like before, we focus on the inside and outside. So anything on the outside is vertical. So the negative on the outside is a vertical flip. The negative on the inside of the notation represents a horizontal flip. So we have seen vertical flips before with parabolas. And so when we have a negative in front of the parabola, the x squared in the parabola, it's going to be upside down u. The positive is going to be the u on the right side up. So we've done that before, so we're going to focus more on the horizontal. What does a horizontal flip look like? Okay, so that horizontal, the x on the inside, what does it do to the graph? So we're going to start with the square root function, and we're going to start with the perfect square coordinates. So these are our reference points. Here are whole number coordinates. And this represents our basic square root function. So what happens as we do a transformation on x? Well, first of all, we've done nothing on the outside. So there's nothing on the outside of the f of x. So nothing on the y changes. So I'm just going to transform all the y coordinates first. Okay, or transfer them. Okay, so nothing changes on the y. These need to all be the same. So where does this 0 coordinate end up when we do the negative transformation? So we probably don't need to do this, but I'm just going to do it anyways. We show that it's consistent. So this is our new x. So this is our old x. Our new x here. That gets to our old x. So if I want to know the transformation, I can just switch that negative to the other side. So this is my notation. This is my description. Now it happens to look the same, but again, it's consistent. We should see that it does work, and when we apply it to the negative, it does work as well. So when we put it through our notation, we're going to end up taking all the positive x coordinates, making them the opposite. So the 0 becomes 0. The 1 now is on the other side, negative 1. The 4 becomes negative 4. The 9 becomes negative 9. The 16 becomes negative 16. And what ends up happening when I graph these points out is the coordinate that used to be over here at 1, 1 is now at negative 1, 1. Okay, the coordinate that was at 4 over 1, 2 up is now at 4 over negative 4 over 2 up. And then at 9, 3 is now at negative 9, 3. Okay, so we end up with the exact same graph, but now it's been reflected horizontally. Okay, so it's now, instead of pointing to the right, it's pointing to the left. So there's a horizontal, ends up being a horizontal flip. Okay, it's a horizontal flip across the y-axis. So this is what the negative does. The negative in front of the x is going to make it a horizontal flip. Okay, and this bit here, bit of algebra here, just shows that it's consistent with what we've done before. Again, it's probably unnecessary because when we see that negative, okay, we know we're just going to make the opposite axis.